Okay, this is the Module 7 skill builder entitled Name That Charge. Just like any other skill builder, there's nothing to turn in for this one. This is not for a grade. This is just for to help you understand the basics of electrical charge, which includes negative charges. Quite often those are electrons, and positive charges. Usually those are the protons or the nuclei of an atom. And how these charges move and the basic characteristics of two different types of materials, insulators and conductors. So you may want to do a little bit of reading to get you some background on what insulators and conductors are. So for this first, I'm going to do one of these questions just to show you how this whole thing works. So it says a negatively charged balloon is brought near a neutral conducting sphere. Uh, the sphere is then, and it's mounted on an insulating stand. So again, it's very important you understand the difference between conducting materials and insulating materials. The sphere is then touched by a person and the balloon is moved away. And there's actually a little animation which will show you what's going on. So we bring this balloon, this negative balloon, close to a metal sphere. Now, this is a metal sphere, so it is a conductor, which means that its charges can move quite freely. In fact, in metals, it's the electrons that are essentially free to move around. So when we bring the negative balloon close but not touching, the electrons in the balloon repel the electrons in the sphere. So the right side of the sphere effectively becomes negative. So overall the sphere is neutral, but the charges can be separated because the negative balloon comes close. So it actually causes the electrons to gather on the right side of the sphere, and therefore the left side of your sphere winds up being slightly positive. The right side becomes slightly negative, an excess of electrons. Then we touch the uh, the, the sphere, and that essentially creates a pathway, a ground, that allows some of the electrons to leave the sphere, go into the person. And so then when the person is moved away and the balloon's moved away, we have a sphere that used to be neutral, but then it lost some of its electrons. So it winds up being overall, it becomes positive. It has more positives than negatives. And that's what we have to then answer. What's the charge on the balloon? Well, notice the balloon never touched anything. So it had an excess of negative charges to begin with, and that hasn't changed. So the charge on the balloon is still negative. It didn't come into contact. We only, and then what's the charge on the metal sphere? Well, it is positive. So notice we started out with a neutral metal sphere, and we caused it to become positive, not by coming into contact with it with a charged object. It wasn't conduction that caused the change in this sphere's charge. It was what's called induction. We were able to induce a charge in the sphere by virtue of the fact that we brought the negative balloon close to it, which caused the charges in the neutral sphere to become polarized. The positives were attracted to the negative balloon, the negatives were repelled by the negative balloon. And then the person created a pathway for those electrons to leave the sphere, go into the person. So when we removed everything away, you were left with an excess or a surplus of positive charges on the sphere, and therefore it was a positive sphere after it was all said and done. And again, you can check your answer, and sure enough, we're correct. And there's 7 other uh, situations that you can go through to make sure you understand how this all works. So good luck.